If you're using a mobile device, then you are partaking in some kind of wireless network connectivity. And even if you're not using a mobile device, you still can. Whether we're connecting to the nearest cell phone tower, connecting to a Wi-Fi router, or even in closer range connecting to a Bluetooth wireless device. But there are some considerations when it comes to troubleshooting things like Wi-Fi connectivity, one of which is a weak or low radio frequency signal. Wireless communications uses radio frequencies or radio waves sent through the air to communicate and to carry data. However, over distance, the signal degrades. What can we do about that? Well, one of the things that we can do is use an extender. So if we've got a wireless network, a Wi-Fi hotspot, and we need to extend its range over a longer distance, we can use a Wi-Fi extender to extend the wireless network even further. And we can also use a higher gain antenna. There are many external antennas that we can either purchase or even create so that we get a better RF signal over a longer distance. We then need to think about things like interference. For example, if you're using the 2.4 gigahertz range for a Wi-Fi network, there are some other things that also might interfere at that same frequency or near that frequency. Things like baby monitors or cordless phone systems that use the 2.4 gigahertz range, or even microwave ovens. Another issue is a hidden SSID. The SSID is the wireless network name, and it can be configured on a wireless router to be suppressed so that you don't see it when you're browsing looking for local Wi-Fi networks to connect to. Instead, you'd have to enter the name manually. Wireless networks can also use MAC address filtering. The MAC address is the 48-bit physical or hardware address assigned to your network interface card. And so on a Wi-Fi router, we can make a list of allowed MAC addresses or disallowed MAC addresses. In some cases, we might also have a problem where an authentication server is unavailable. So instead of the Wi-Fi router itself doing authentication, instead of just using a Wi-Fi password, such as for WPA2, we can configure the Wi-Fi router to forward client authentication requests to an authentication server that's elsewhere on the network. And so if we've got a problem where that authentication server cannot be reached, it means users will not be able to authenticate to the Wi-Fi network, even though the Wi-Fi router is functional. There are also configurations that allow the use of a PKI digital security certificate to uniquely identify a user or a device before connectivity to the network is allowed. Now, if that certificate has expired, it's no longer usable. That would prevent connectivity to the Wi-Fi network. Or if the certificate was revoked by an administrator, perhaps due to a security breach, again, the certificate won't be able to be used to successfully authenticate to a Wi-Fi network. If there's slow network performance, one of the reasons that will happen is we might have too many concurrently connected devices. So if we state that we've got a Wi-Fi network that runs at 600 megabits per second, that gets divided up among all of the concurrently connected devices. They don't each get 600 megabits per second. So we have to bear that in mind when thinking about slow network performance. Pictured on the screen, we see a Wi-Fi extender plugged into an AC electrical outlet. Notice that we can also plug a wired RJ45 type of cable into it. Now you might do that to configure it, or if you've got a device nearby that does not have a Wi-Fi card, you could plug it into this so it can make a connection to the network. But also the purpose here is that this Wi-Fi extender should be placed towards the reasonable outer perimeter of where the signal strength is currently good so that it can extend the range even further. For example, throughout a larger building or across a larger property.